This video is about Chapter 4. And in this video, we'll talk about displaying and summarizing quantitative data. By the end of this video, you should be able to display quantitative data using histograms and relative frequency histograms, stem and leaf displays, and dot plots. You should also be able to describe a distribution by talking about the shape, center, spread, and unusual features of that distribution. You should also be able to discuss ways of measuring the center and ways of measuring the spread for a distribution. The first way that we can display quantitative data is by using a histogram. Okay? Notice that there are no gaps in the data, as we saw with a bar chart for categorical data. Okay? The reason there are no gaps is because it makes sense for the data to come right after each other because the numbers are connected and continuous. Okay? So when we display a histogram, there are no gaps in the data. Okay? Also notice that on the side here, we have the number of earthquakes. Okay? And that is different from a relative frequency histogram, where on the side we have a percent. Okay? It's a relative frequency. Whenever you hear the term relative frequency, usually it involves percents. Okay? So a relative frequency histogram is like a histogram with no gaps. Okay, but on the y-axis we have the percent of earthquakes, not the number of earthquakes. Next, there are stem and leaf displays. You may have seen these before, but these are usually used when you have smaller sets of data, somewhere between 15 and 40 data points or so, smaller data sets. On the left-hand side, you have the stem, which are the leading digit or digits. There could be more than one. And the right-hand side are the leaves, which are the ending digits, usually 1, but it could be 2. Okay. Also, please note down here, there's a legend that tells you that this digit means 88, and that helps you to know that it isn't 880 or 8,800 or some other number. Okay. Now, I want to point out that this happens somewhat frequently in that when you have lots of numbers that are bunched together, that we sometimes break up our stems to be more than one. So here are the smaller digits from 0 to 4, and here are the digits from 5 to 9. Okay, that happens all the way up, 0 to 4, and then 5 to 9. Okay, so you can separate them if there are lots of numbers that are bunched together. Okay, next are dot plots. You simply place a dot for each data point, usually integers, which is similar to a histogram, but they're drawn in dots instead of bars. Okay, the next really important concept is how you describe a distribution. You talk about shape, center, spread, and unusual features. Okay, I will say that again because it is so important. When you're asked to describe a distribution, you talk about the shape, center, spread, and unusual features. Okay, we'll talk about shape next. When you're describing the shape, you can talk about how many modes. Okay, is it unimodal, meaning it has one mode, there's one peak, or it could be bimodal, where there are 2 peaks. It could be multimodal, where there's 3 or perhaps more. Or it could be uniform, where it's roughly the same all the way across. Okay, those are the 4 ways of describing the mode of our graph. Okay, also when describing the shape, you should talk about its symmetry. Is it symmetric or is it skewed? Okay, if it's symmetric, then on both sides of the graph it should look roughly the same. Okay, and you should be forgiving because real data never looks nice. Okay, or is it skewed, meaning there's more on one side than on the other? Okay, now we call this left skewed if the tail, the place where there's more, the data goes out farther, is on the left. Okay, so you follow the tail. It's right skewed if there are more data on the, not more data, but if the data is more spread out on the right side. Okay. Also, when talking about the shape, or I guess these are unusual features, you talk about things like outliers and gaps. Okay, outliers are when one or more data points kind of stand away from the rest of the data. Something's different about that point. Okay, and in the next chapter, we will talk about a mathematical rule of thumb to know if something is far enough to be an outlier or not. Okay, for right now, we'll just call it a point that stands away from the rest of the data. Okay, another unusual feature are gaps in the data. Okay, now gaps are several bins, or there's some space between the data sets. Okay, so I would consider this a gap because you have about 3 spaces where there's no data. Okay, I would not consider this a gap because there's only one, and this is 1 point and this is 1 point, and so there just happened not to be anyone who was between 80 and 90 years old in our data. Next, we will talk about measuring the center. There are 2 main ways that we measure the center of a data set. The first is the median. Okay, and the median is the middle number. Okay, now here's some data that we will use throughout this video that I just made up, but I was thinking about GPAs when I made them. Okay, now the median is the middle number. Now there are 10 points here, and so the middle number is not going to be the 5th one. Okay, the middle number will be between the 5th and the 6th, because on both sides I have 5 data points. Okay, so if there is a middle number, like if I had 9 or 11, then I would just simply pick the middle number. Okay, but here I have an even number of data points. I have 10, and so it's somewhere in between the 5th and the 6th number, and so I will actually find the average of these 2, which is 3.1, or the number right between them. Okay, that is the middle number. It's the median. Okay, now one nice thing about the median is that it splits the histogram into 2 equal halves. There are the same amount of data on the left hand and the right hand of the median. The other way of measuring the center is by using the mean. The mean is the arithmetic average. You add up all the numbers and divide by the number of numbers. So in this case, I add up my 10 GPAs and divide by 10, and that will give me the mean GPA. So if I add up these 10 numbers, I get 29 divided by 10 is 2.9, and the mean, or the average, is 2.9. Now the mean also feels like the center because it is the point where the histogram balances. It takes into account all the data points and finds the place where it balances nicely. Okay, so which one do you use? Do you use the mean or the median? Okay, both seem to have some merit as far as what should be called the center. Okay, but some of them make a little more sense. For example, in this picture, the mean is at a point in the graph where there is no data. So it feels strange to me to call the center of the graph a point where there is no data. Similarly, down here, because it's symmetric and unimodal, it seems like either one would be a good way of measuring the center. Okay? Now, our rule of thumb of which to use is this. If the data is symmetric and unimodal, we use the mean. Okay? If it's not symmetric or not unimodal, then we use the median. Okay? In general, we use the mean whenever possible because you'll find there are some other tools that use the mean that are very useful to us. So we use the mean whenever possible, but if the data is highly skewed or bimodal, then we use the median instead. Next, we will talk about measuring the spread. Okay, there are several ways to measure the spread. The first way is called the range. Now the range is the span of numbers. Okay, it is found by taking the maximum number, the biggest number, and subtracting the smallest number. So in my data of GPAs, the range is 4.0 minus 1.4 and gives us 2.6. Okay, that is the range, the span of numbers in this data set. Now, the range has some major problems in that it is highly variable if there are outliers, because it just takes the biggest and the smallest number, and so it's not a really reliable way of measuring the spread of a data set. Another way of measuring the spread is by using the interquartile range. Okay, now before I can talk about the interquartile range, I must talk about what a quartile is. A quartile breaks up the data into quarters. That's why it's quartile. Okay, now we found earlier that the median is right in the middle here at 3.1. Okay, so if I then look at this data set, this lower half, and find its median, I come up with the value 2.2. Okay, and if I look at this upper half and find its median, I come up with 3.5. Okay, now this is the first quartile, or called Q1, and this is the third quartile, Q3. Okay, now we could call the median Q2 because it cuts the data in the second quarter, but instead of using Q2, we almost always call it the median. The interquartile range is the span between Q1 and Q3. Okay, here is the formula. Now, the nice thing about the IQR, or the interquartile range, is that it's not really skewed by outliers. It doesn't matter how far the outliers are, it still deals with Q1 and Q3, and so it's a fairly good measure of spread for us. Okay, so in this example of GPAs, the IQR is 3.5 minus 2.2, which is 1.3, is the IQR in this data. Another way of measuring the spread is something called the standard deviation. The standard deviation is a measure of spread that tells how much the data values differ from the mean. So we're comparing each data point with the mean. Okay, so before we can really find the standard deviation, we must first find the mean. And we found the mean earlier in this video as 2.9. Okay, so let me walk you through this. We take each data value and we subtract the mean and find the deviations from the mean. Okay, now some are positive and some are negative. If we simply added up this set of numbers, we'd get 0, which is not very helpful to us. Okay, so the way we deal with the positives and the negatives is we square them. Okay, we square each number, and that makes all the data positive. It makes the numbers that are far away even farther, and the numbers that are close very small as you square a number. Okay, and then we add up those numbers. Okay, so here is the sum of this set of numbers. Okay, now if we had a data set of 100 values, okay, that would make that sum very large, and so the way we kind of compensate for how many numbers we are adding up is we divide by n minus 1. I'll talk about why it's minus 1 later on in the year. Okay, divide by n minus 1, and that number actually has some useful properties to it. That number is called the variance. Okay, and has some nice properties we'll talk about later on in the year. Okay, now when we take the square root of that number, this number down here, that gives us the standard deviation. Okay, it's a long process, but it's a way of measuring the center and has some very powerful properties that we'll be using quite frequently throughout this year. So here are the formulas for the variance and for the standard deviation. Okay, in case you're not familiar with this symbol, It is the summation sign, and it means to find the sum of all the things after the sign. Okay, so for the variance, we took each data point, subtracted the mean, and found that difference, or that deviation, squared, and then we added up all those squared deviations and then divided by n minus 1. And then to find the standard deviation, we then took the square root of that number. Okay, we'll talk more about these formulas. You do not need to memorize these formulas. Okay, we will almost always use a calculator to calculate them, but you need to be familiar with where they come from. It gives you a really good intuition with these numbers. So, of the 3 ways of measuring the spread, range, IQR, standard deviation, which one do we use? Okay, well the answer is you never use the range. It's a terrible way of measuring the spread, so don't use it. Okay, the IQR is useful in some cases, and the standard deviation is also useful in some cases. And it boils down to the discussion earlier about measuring the center. When the data is symmetric and unimodal, then use the standard deviation. It's a powerful tool that has some powerful properties. If it is not symmetric and unimodal, then use the IQR to measure the spread. So this video was about displaying quantitative data. It was about describing a distribution using shape, center, spread, and unusual features. And we also talked about ways of measuring the center and ways of measuring spread. Thank you so much for watching.